If you have issues with your analog readings being incorrect, that could possibly be caused by high input impedance. So first things first though, you'll notice the camera's not on my face, it is on my cat. Her name is Sylvie and she is exceptionally cute. So something else I also want to mention. A few hours ago, I just got done rewatching Your Light in April. Listen, there are shows out there that hit you in the feels. This thing, absolute freight train through your feels and through your very soul. Highly recommended you watch it. Watch it alone, because you're gonna cry. And you're gonna cry a lot if it's your first time you've seen it. So, anyways, high input impedance. So if we go back to what a ADC does, it's probably, if you're a microcontroller, it's probably, not guaranteed, going to be a sample and hold ADC converter. So as you can see, we have an RC time constant going on here. So if this is all messed up, well, then your readings are also going to be messed up. But not only that, if you, here, let's get the camera back onto me. So if one of these is, so if this is all messed up, then you can mess up other channels on your ADC. It's called channel-to-channel crosstalk. So what's going on over here is this is our input resistance as seen by the analog pin. And you'll notice this is in series with the resistance of this ADC. So you can have a big RC time constant, you can screw it all up. So what you'll see in a data sheet is probably a one-liner like this. External input impedance, maximum 50k ohms. And that's as far as most people go. I can't tell you about an ST chip, but I can tell you for a ATmega 328P, what is listed is bullshit. Totally wrong. You can lower it like quite a bit to what it says and a little bit below. No, it's still off. It's better, but it's still pretty off. ST, what they'll do is that they'll show you how they got to that 50k ohms. So basically, slow things down is what they're saying. And yeah, that's one way of mitigating this issue is if you look in the data sheet, you can change the sampling time. So in this case, up to 160.5 ADC clock cycles. So then you'll say, okay, what's clock cycle? You can change that too for your ADC clock. So you can do all kinds of dividers. So in this case, I'm doing something that's very common, at least in my neck of the woods, which is I have some kind of regulator and I want to measure it to make sure it's within some kind of norm. So usually for this type of application, I do my pass-fail criteria is plus minus 5%. Just because when regulators fail, they tend to fail, they are way off. So one solution you can do is just change your firmware, change the timing, which you might want to do anyways. Just think about it. Especially with this clock cycle, faster means more power. So for your battery life, you want it low anyways. There's some other things you can do, such as the ADC doesn't turn on until there's an interrupt or something like that. That might be fine, but I don't think it'll solve this issue. So while I do like mitigating in software, I do like fixing hardware problems in hardware. So one way we can do that is we'll take this guy and just stick a cap right there. So I didn't come up with this idea all on my own. I got it from a Texas Instrument white paper. If you want to Google it, this SPNA 061. So it might be over 20 years old, but it's still right. So to spare you all the details, which this is actually a rather interesting white paper. To be honest, you might want to Google it and actually read it. It's not that long. So what they determined was, okay, if you do this, you will lower the impedance as seen by the input pin. So, and the value they determined was 41 nanofarads. So, I don't have that value. So they also determined that bigger is better, but you hit, after that 40, 41, you hit diminishing returns rather fast. So 0.1 is good. I have actually done this. It does like pretty darn good. But if you're in some situation where pretty good won't cut it, then you'll need to do better. So for this issue here, I have seen senior engineers miss it. So they would just do something like this. So I've had to correct them and say, that's not the full story. So since utter accuracy is not required, just add a cap and be done with it. This is your it's a good solution. I'll put it that way. It's not best, but it's easy and it's good. So this is my go-to. Another thing you can do, add an op amp. So in general, I try to stay away from op amps unless it's one of the default configurations you can just Google. But, since I mainly deal with digital circuits, I have that luxury. So this is just an ordinary, they call it a unity gain or a voltage follower configuration. So your output voltage is going to match your input voltage. So the reason this works, the reason why it's such a slick solution, is that your ideal op amp here is going to have infinite input resistance. So why does that matter? Well, if whatever you have here is not incredibly high, that's going to mess with the voltage that's coming off with this divider, because it's going to be in parallel with this resistor right there, which we don't want. But since this is so absolutely gargantuan, it's not going to affect the voltage. We like that. So if you go into a data sheet, let's see, input impedance, these guys up here. So the way they do it is a little bit funky, but here, mega ohms and whatever 10 to the 13th ohms is. So plenty high. So also, oh, wrong one. Your ideal op amp is going to have 0 output resistance, which is absolutely perfect because we want low. We want this resistance to our analog pin to be low. So this configuration just with an op amp is like a match made in heaven. The input does exactly what we want. The output does exactly what we want. Here, this output on this particular one, 60 ohms at 1 megahertz, but we're at DC. So that is much, much better. So, but there is a non-technical problem you will face. I have had engineers not believe this will work. So what they may have you do is put a 0 ohm resistor at an optional 0 ohm resistor that bypasses this whole thing. Just in case it doesn't work. I've had to do that. I've had to test. What happens if we do the 0 ohm and not populate this? Yeah, no surprise. It don't work. So another thing I have seen is somebody try to be smart and combine both options. So if this works, then if this works and this works, if you add them together, it'll super duper really work. No. What will happen is that op amps and output capacitance, this can make your output ripple. So, which is no good. So, one or the other. So, slow it down in firmware. You could lower these at the expense of battery life, but won't really work. Add a capacitor. In this situation, that works. Remember RC time constants. So if what you're sampling is fast, remember that. Or op amp. So op amps have some areas where they can add some parts where they're not accurate. But I have found just even with a regular op amp for the stuff I do at work. So I've had to have some cases where this ain't gonna fly, but this did. I used just a regular general purpose op amp. So this will probably work. If that doesn't, you can get better op amps out there. So, all right, guys. So remember, if you got weird stuff going on your analog readings, check the impedance and then fix the impedance. All right. Thank you, guys. Like this video if you liked it. Bye.